In this video, we are going to be discussing perfect squares and square roots. So let's first discuss what it means to square a number. Squaring a number simply means multiplying a number by itself. For example, 7 squared is just equal to 7 times 7, which is 49. Another way of thinking about it is if I draw myself a square, we know that in a square, all of the side lengths are the same. So if I say this side is of length 7, then so is this side. And you know the area of a square is simply the length times the width, which is 7 times 7, which is 49. So that's where we get the term squaring. It is literally finding the area of a square with this side length. So what does it mean to take the square root of a number? Well, square rooting a number, the square root of a number is that special value that when multiplied by itself gives our original number. So for example, we know 8 times 8 equals 64, so the square root of 64 is equal to 8. If we think of our square model, if I say that the area of this square is 64, then it means that the side length is equal to 8. So that's what it means to both square a number and to take the square root. Squaring a number is multiplying it by itself, or multiplying a number by itself, and taking the square root is just going the opposite of that. Finding a value that when it is multiplied by itself will give us the number we're looking for. So, our next question is, what is a perfect square? And a perfect square is just a special number whose square root is an integer. All right? So, for example, 36 is a perfect square since the square root of 36 equals 6. We know that because 6 times 6 equals 36. A number that would not be a perfect square would be like the square root of 3. Square root of 3 is like 1.7 something, 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 on and on and on forever. It's an irrational number. It is not an integer, so it cannot be a perfect square. 36 is a perfect square. Another example would be like 4, because that's 2 times 2. Or 81, because that's 9 times 9. And you are going to be responsible for memorizing the first 20 of these perfect squares. So, let's go ahead and talk about what they are. All right, so here are the first 20 perfect squares. And I'm just going to gradually show them to you. And I would like you to copy down the chart that I'm making on your notes. So here are our first 5 perfect squares. We know 1 times 1 gives us 1. 2 times 2 gives us 4. 3 times 3 gives us 9. 4 times 4 is 16. And 5 times 5 is 25. So these numbers, 1, 4, 9, 16, and 25, these are the first 5 perfect squares. All right? Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. And the square root of 25 is 5. All right, our next 5 are 36, 49, 61, or 64, 81, and 100. So 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. These are our second 5 perfect squares. Okay, these 10 are the ones that I would expect you already know. The second group of 10 perfect squares are these. So we've got 11 times 11, which is 121, 12 times 12, which is 144, 13 times 13, which is 169, 14 times 14, which is 196, 15 times 15, which is 225, 16 times 16, which is 264. Sorry, that's not correct. Don't know how that got in there. It's not 264, it's 256. 17 times 17, which is 289. 18 times 18, which is 324. 19 times 19, which is 361. And 20 times 20, which is 400. Now, it is expected that you memorize these. However, you don't necessarily have to. Whenever you're not sure exactly what the perfect squares are, you can always just take and use your calculator and say, oh, well, 19 squared is 19 times 19. That is 361. So that is a perfect square. So Let's look at some examples of what we can use these for. Here's a problem. Is 246 a perfect square? Well, in order for it to be a perfect square, we know that the square root of 246 has to be an integer. Well, let's go back and look at our table. Let's see if we can find some numbers that are near 246. We see we've got 225 here. That's 15 squared. So we've got 15 squared. Or we can say the square root of 225. That's 15. And then on the other side of 246, we have 256. And we know the square root of 256 is 16. So now we got to ask ourselves, well, 246, that's between 225 and 256. I know the square root of 225 is 15. I know the square root of 256 is 16. These are two consecutive integers. There's no integer in between them here. So, can 246 be a perfect square? No, it can't. Because its square root is not going to be an integer. Therefore, this cannot be a perfect square. So, question we ask ourselves is, what is the square root of 246? Well, it's more than 15, it's less than 16, so it's going to be more than 15, less than 16, so it's going to be 15 point something, 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 something. It doesn't really matter. The question is just asking, is it a perfect square? We know it's not an integer, so the answer is no. Let's look at a second example. Second example says, between what two integers is the square root of 75? So we know that the square root of 75 is not a perfect square. What we want to find here is we want to think, what are two perfect squares that 75 is between? If you look at your table, you see that just bigger than 75 is 81, and just a bit smaller than 75 is 64. All right? If we take the square roots of all three of these numbers, the square root of 64, that's 8. The square root of 81, that's 9. The square root of 75 is going to have to be between these two things, so it's going to be between 8 and 9. So if I make myself a number line here and I say, okay, here's 8, okay, here's 9, square root of 75 is going to go in between here. Well, which one is it closer to? That's the question we want to ask. Is it closer to 8 or is it closer to 9? Well, 64 to 75, that's 9. That's the difference between these two is 9. Difference between these two is 6. So 75 is closer to 81 than it is to 64. So the square root of 75 will be closer to 9 than it is to 8. So I'm going to draw this right here and say that this right here, that is the square root of 75. So we can see that if we are given a number, we can find two perfect squares that it's between, whether or not it's a perfect square. Like, take for example, if we were to look at a new problem, what if I asked you between what two integers is the square root of 182? Pause the video for a second here and see if you can figure out between what two numbers on here and over here, between what two integers is the square root of 182. Pause the video for a second and try and figure that out. All right, let's see what our answer is. If I look and try and find the next perfect square that is closest to 182 but smaller than it, I get 169. So I'm going to find the square root of 169. I know that's going to be the perfect square that is smallest or smaller than 182. And the next perfect square that is bigger than 182 is 196. So if I take the square roots of these two numbers, square root of 169 is 13. Square root of 196 is 14. So my answer is going to be that 182 is somewhere in the middle here between 13 and 14. Now, if I find the difference between these numbers, I can find which it's closer to. 182 minus 169 is 13. 196 minus 182 is 14. So this number is going to be closer to 13 than it is to 14. But these are the two numbers, the two integers that the square root of 182 is between. So I'm going to leave you with this try-it problem. What you need to do is draw yourself a number line and put these numbers up here, 12, the square root of 132, the square root of 169, 11, and 14, in order on this number line using the information that you now know about square roots.